Alrighty, lesson 1.3, linear equations in two variables, refreshing your algebra memory here. Alright, so sketch the lines through the point with the indicated slopes on the same set of coordinate axes. Alright, we have a point, negative 4, 1, negative 4, 1, negative 4, 1. Alright, there's our point, and we have to apply all these slopes. Alright, so we have to draw a line that has these slopes passing through this point. So we just start from this point, and for 3, slope of 3, we have 3 over 1. So I go up 3, and over 1. And you can do the same thing going backwards, down 3, back 1. All right, and there's one line. I don't have a ruler. Okay, so that's, we'll call that line A. And then line B, negative 3 over 1. So instead of going up, we start first by going down. 1, 2, 3. And then we go right 1. And then we go backwards, we go up 3, and we go left 1. Okay, that's line B. And then you have line C, up 1 over 2, up 1 over 2, and then down 1, back 2. All right. That's up 1 over 2 again. All right, that's good. And that's C. And then D is undefined. So when would you have an undefined slope? Well, that's whenever you're dividing by 0. It doesn't matter what the number is on top. So if the denominator is 0, that means you are not moving left or right at all. You're just going up and down. All right, so it doesn't matter what that number is. You're just going to keep going up and keep going down. You never go left or right at all. So that's D. And then 0, all right, it doesn't matter what the number is on the bottom. If it's 0 on top, then you don't go up or down at all. You simply go left and right. So here I am going through the point, and that's going to be E. All right, going on to example 2. For example 2, estimate the slope. All right, so slope is rise over run. We have to find 2 lattice points that the line passes through. Lattice points are where the grid lines cross. All right, so there I have my 2. Now I could go rise, which is 5, over run. So 5 over 2. Or you could just as well go rise, in this case, which is going down, and then run, which is negative 2. And that still simplifies to 5 over 2. So your slope is 5 over 2. On to the next example. All right, use the point and slope of a line to find one additional point through which the line passes. Okay, well, recall that this equation of a line is y equals mx plus b. They give you the slope, and they give you a point. Well, the point represents your x and y values, so let's plug all the information in. We have negative 6 equals m, which is negative a half, times x, which is negative 1, plus b. So I have negative 6 equals a half plus b. Then I'll subtract a half. All right, and I have negative 6 over 1 minus 1 over 2. Need to find a common denominator. So I have negative 12 over 2 minus 1 over 2 equals b. So b equals negative 13 over 2. All right, we're going to use that piece of information in just a moment. Let's plug it back in to the equation. All right, so to construct our equation, we need to have m in it, which is negative a half. And I need to have b in it, which is negative 13 over 2. Okay, and now I need to find another point. So it's your choice. You want to find a point? Let's just plug in 1 for x. All right, and we'll find which y value is associated with 1 for x. So let's plug that in. We have negative a half times 1 minus 13 over 2. So negative a half minus 13 over 2. negative 14 over 2. So y is equal to negative 7. All right, so there's the other point. I plugged in 1 for x, and negative 7 goes along with 1. Negative 7 for y. All right, that's example 3. Going on to the next example. Find the slope-intercept form of the equation of the line passing through the point. Sketch the line. Okay, so once again, equation of a line is y equals mx plus b. They give us 2 points here. They didn't give us the m, so we need to figure out the m. Well, I could call this x1, y1, and I could call this x2, y2. All right. And then my slope formula is y1 minus y2 over x1 minus x2. Now, you could have just as well written y2 minus y1 over x2 minus x1, and you'll get the same result. Doesn't matter what order you have them in. Just be consistent with the ordering. Okay, so we have y1, which is 3, y2, which is negative 4. Be careful with those negatives. x1 is 4 minus x2, which is negative 4. All right, so I get 3 plus 4, and I get 4 plus 4, so I get 7/8. Okay, now I could plug that into my equation. All right, but I still have to figure out what b is. All right, how am I going to do that? Well, you just pick one of these 2 points, plug in the x and y values, and you'll solve for b. I'll choose the positive values. So I have 3 equals 7/8 times 4 plus b. All right, you could look at it this way. 4 goes into 4 once, 4 goes into 8 twice. So I get 3 equals 7/2 plus b. All right, got some fractions to work with here. All right, don't freak out. Just take your time. Sorry, I'm a little all over the place here. All right, I still need to find a common denominator. So I have 6 over 2 minus 7 over 2 equals b. So I get negative 1/2 equals b, or 0.5. So constructing my equation, I have y equals 7/8 x, and b is negative 1/2. All right, I have to graph this now. So I'm starting at negative 1/2. And then my slope is 7/8. All right, so you just got to be careful of this. Rise, 1, 2, 3, 4, 5, 6, 7, and to the right, 8. 1, 2, 3, 4, 5, 6, 7, 8. And going backwards as well. 1, 2, 3, 4, 5, 6, 7, and then 1, 2, 3, 4, 5, 6, 7, 8. Alrighty. And there's your line. Going on to the last example. Alright, example 5. Before we get started, what is special about the slopes of parallel lines? Well, the slopes are equal. Alright, for perpendicular lines, the slopes are opposite reciprocals, or negative reciprocals. All right, so for example 5, write the slope-intercept forms of the equations of the lines for the given point. They're parallel to the given line and perpendicular to the given line. All right, so they give us this equation here. I'm going to isolate y. Y is equal to negative x plus 7. Okay, so I have this line here, and I need to construct another equation that's parallel to this line that passes through this point. And for part B, it has to be perpendicular to this line that passes through this point. All right, so for part A, working with the parallel case, 2 vertical lines, that's the parallel symbol. All right, so y is equal to, well, what's my slope going to be if I want the lines to be parallel to each other? Well, the slopes have to be equal, so I'll use -1 as well. All right, still have to figure out what b is. How do you figure out b? Well, they gave you this point here. All right, so we have x, y, plug those values in. All right, so f2 is equal to 3 plus b, subtract 3, b is equal to negative 1. So plugging the b value in, I get y is equal to negative x minus 1. All right, so this equation is parallel to the graph of that equation. All right, now going on to the perpendicular case. All right, and upside down t, that's the symbol for perpendicular. All right, what's my slope going to be in this case? Well, the original slope I'm working with over here is negative 1. So I need to find the opposite reciprocal. So that means I flip this fraction and I change the sign. So it's negative, now it's positive. All right, so setting up my equation, I have y equals m in this case is 1, x plus b. All right, same deal as before, plug in the x and y value from the point that they give you. And that's y. Okay, so we have 2 is equal to 1 times negative 3 plus b. We have 2 is equal to negative 3 plus b. And I'm going to add 3 now. And I get b is equal to 5. So completing my equation, I have y is equal to 1x, or just x, plus b. And b is 5. All right, so that's the equation that's perpendicular to the graph of this equation. All right, that's all there is to it. All right, begin the assignment at the bottom of the web page. Make sure to ask for help if you need any.